A Poundland winter beanie with LED light. I suppose it could be a summer beanie as well. Do you call them beanies where you are? They're called beanies here, just a woolly hat. Very popular, particularly on an island like Isle of Man, especially LEDs because you need LED lights when you're in the Isle of Man because it's a very dark place. But this cost £5 or €6, and it is USB rechargeable. Now, to save time, I'm going to pop this out. It's worth mentioning it can pop out if you hold the little frame at the side and you squeeze the middle. It pops out. Let us explore it in greater detail. When this arrived, I had a little dab of glue in it to hold it in place. I think that might have just been for shipping because it means you can wash this hat without worrying about damaging this. So you've got one button and it goes through high intensity, medium intensity. You can see the pulse width modulation. Let's zoom down on this because that's probably a good idea. And it's got low intensity with even more visible pulse width modulation. And then it goes into strobe mode where it's just a slow strobe. It's worth mentioning a couple of things. If you press and hold it for a long period of time, it does not go into SOS mode, which is good. But also, even if you have it on, say, full intensity for several minutes, it doesn't seem to do that thing that some do, that one press actually turns it off. You have to click through all the modes. If you want to charge it, you pull this little thing off and it reveals the side of the circuit board, which is quite nice. And if you then plug it into a USB power supply, actually, you know what, let's get a charge monitor here. Where is a charge monitor? I'm pretty sure I had a charge monitor handy. Apparently not. Right, just give me one moment, I'll find a little charge monitor. I have found my Rodang charge monitor. I shall plug this in, and the little red LED lights, it shows a current of about 200 milliamps. Usually they charge the cells in these at the, well, I'm not sure what size the cell is going to be, but they often charge it at the 1C, which is the capacity of the cell. So it might be a 200 milliamp hour cell, I'm not really sure. Maybe it's also fully charged and the current's gone down. It's not a terribly big thing. Right, I shall put that out the way, and we shall open this. You can see a panel on the back. Oh, that panel is also going through to the front. Does the front come off? Yes, it does. Circuit board. Actually, I thought the circuit board was the same circuit boards going out there, but it's not. There's the lithium cell. Let's explore. It's got no markings on it. Okay, it doesn't look terribly big. I would actually rate that round about 200 milliamp hour. And I tell you what, I shall take a note. I'll take a picture of this and then we can explore the circuit board. One moment, please. And resume. The reverse engineering has been done. It's a very straightforward design. Nothing really radical. Let's just get a little bit closer to this so you can see the layout. The USB supply comes on when you're charging it, and it goes via this diode. The negative is common throughout the whole circuitry, but the positive goes via this Schottky diode to the charge control chip, which is a 57BM. It's just a generic 4057 type charge control chip. And it has a couple of decoupling capacitors and also a 5.1K resistor, which sets the charge current for the lithium cell that connects here. That's going to give a charge current of up to about 250 milliamps. The LED control, the other thing it's got is a couple of LEDs here with a common resistor. That's a little bit of an oddity where they've taken the resistor from, but it's a 680 ohm resistor and then a red LED for charging and a green LED for charge. That's all done through this little charge control chip. The flashing is done with this chip over here, which uses 4 pins. It's called a 2105. It's one of those generic, you know, you're not going to find anything if you search for 2105. But it's the sort of thing you'd find in head torches, flashlights, stuff like that. And I think it can drive LEDs directly by pulling to this 0 volt rail. But in this instance, because it's driving 4 quite chunky LEDs, it's using an A1SHB MOSFET to beef that sort of current up a bit. And then it's got a couple of 15 ohm resistors in series with each pair of LEDs, which then sort of limits the current through them. I have got the lithium cell on charge at the moment. At the moment, it's looking to be round about 200 milliamp hour or just under that. I shall let you know. I'll let you know in the description because I shall know by the time I've finished recording this video. Actually, I probably won't. It's still charging right now. let me show you the schematic. So I'll zoom in a bit further on this. Here is the schematic, and I've added lots of little random notes at the bottom here. I'll explain those later on. So here's the USB coming in, and it goes via that Schottky diode to the 4057 charge control chip. The Schottky diode is useful for two reasons. It protects against reverse polarity, but it also drops a little bit of voltage, and that's useful because this chip here is a little tiny 6-pin chip, and it dissipates any difference between the 5 volts and the battery voltage, the lithium cell voltage, as heat when it's charging. Not that it's really an issue at the low current that it's using. However, that diode will actually drop the voltage slightly, and it will dissipate a little bit of heat, but it will just take a bit of the strain off this chip. Here are the two decoupling capacitors either side, which are just the standard part of that recommended design, which is good they've included them. Normally the 680 ohm resistor would be taken from the same supply rail as this, but they've taken it from the other side of the diode, which is the odd bit. I don't think it really matters that much. But it then goes, that 680 ohm resistor gives a positive supply to the current limited supply to the charge and the full LEDs, and then they just go to the pins in this chip. There's the resistor that sets the charge current, and there's the lithium cell. There is no over discharge protection for the lithium cell, but by the time, well, I'll explain that afterwards. By the time the voltage gets so low the LEDs are quite dim, it's still within a safe level of charge. Here's the little flasher chip, which has the positive connection, negative connection, and a push button that connects to negative. Its output, I presume it could theoretically have LEDs connected directly to it with resistors, but in this case, it pulls low to turn things on. So they've used the classic A1SHB P-channel MOSFET, which is connected to the positive rail. Let's call that just positive. And the A1SHB connects to the positive rail, and when its gate is pulled negative, that's when it turns on. So at the moment, normally it's kept off by that 10k resistor pulling it up to the positive rail. When the chip does turn that on, it powers the 4 LEDs with two 15 ohm resistors, one resistor per 2 LEDs. I measured the current by hot wiring it with my bench meter. I measured the current at full power, high level setting at 173 milliamps. Medium setting was 85 milliamps, low was 42 milliamps, so that's pretty much half and quarter the main output. And the flashing, quite hard because it was a 50-50 ratio, but really slow. So I'm guessing that it's the full current, 173 milliamps, but because it's on half the time, it'll be 85 milliamp. When the battery drops to half voltage, the full setting, the high setting, which was 173 milliamps, will go down to 115 milliamps. And way down when the battery is reaching the point you should stop discharging it. The current is dropped to 10 milliamps at 2.7 volts. So this is one of these things that it's not going to cut off. It's not going to plunge you into the dark. When the batteries run out, it's just going to get dimmer and dimmer, and you're going to end up having to take it off and hold it up to things to be able to see them. But it's not going to just basically desert you and just plunge you into the black. So that is quite good actually. And by the time it gets down there, you'll see it's dim and you'll want to put it in charge. So win-win. It's not really going to over discharge the lithium cell much. But that is it. Not really much else to say. Oh, yes, there is. The charging circuit board is 2 millimeters thick, which is very similar to these little plug-in LEDs. It's a bit thinner than it should be, I think, for the USB ports, because it's a bit wobbly, but it does still make connection. They've really gone to town, the pads here, the tracks, for making that connection. It works quite well. I tried it in a few connectors and wobbled it, and it still made a good connection. So it's low current. It's only about 200 to 250 milliamps anyway, so it doesn't really matter that much. It's given me inspiration, this reckless approach to little USB plug-in circuit boards. I've thought about that for a while. They've taken a much cheaper option than this, but you know, that looks good to me because I'm trash. But there we go. The Poundland USB rechargeable beanie. it's a fairly logical design. There's no real great surprises in it. The only surprise was the way they're actually using the circuit board sticking out the side with this cover over it just to make a fairly neat arrangement. But I'm a bit surprised. I was expecting this to be just an extension of the circuit board inside. I was almost disappointed I found it as a separate circuit board, but that's still okay. It's just a very cheap way of implementing a connector. And in that way, it's a bit inspirational. It gives you ideas and makes you want to explore things. But that is it. I think I've covered everything. I have covered everything, haven't I? There's not much to cover. It's a textbook design.